Can you explain the concept of lazy loading in Angular? Lazy loading is a technique in Angular that allows you to load modules or components on demand rather than all at once when the application starts up. This can help to reduce the initial load time of your application and improve the overall performance. In a typical Angular application, all the modules and components are loaded when the application starts up. However, this can result in a longer initial load time, especially for larger applications. With lazy loading, you can split your application into smaller modules and load them only when they are needed. To use lazy loading in Angular, you can use the load children property in the routing configuration of your application. This property allows you to specify the path to the module that should be loaded lazily when a particular route is accessed. Here is an example. In this example, we have defined 3 routes for our application. The load children property is used to load the lazy module lazily when the lazy route is accessed. When the user navigates to the lazy route, Angular will load the lazy module and its components on demand rather than all at once. By using lazy loading, you can significantly improve the performance of your Angular application by reducing the initial load time and only loading the modules and components that are needed when they are needed. What are the change detection strategies in Angular? In Angular, the most common way to detect changes in data is through the change detection mechanism. The change detection mechanism is responsible for checking if there are any changes in the component's data and updating the view accordingly. Angular provides 2 ways to implement change detection. Default change detection strategy. By default, Angular uses the default change detection strategy. In this strategy, Angular checks for changes in all the components and their child components whenever an event occurs or a data is updated. This approach is not recommended for larger applications as it can lead to performance issues and slow down the application. On-push change detection strategy. The on-push change detection strategy is an optimized approach to detecting changes in data. In this strategy, Angular only checks for changes in the component's data and its input properties. If there are no changes, Angular skips the change detection process for that component and its child components. This approach significantly improves performance, especially in larger applications. To use the on-push change detection strategy, you need to set the change detection property of your component to change detection strategy .onPush like this. In summary, the on-push change detection strategy is the recommended approach for performance optimization in Angular applications. How would you implement authentication and authorization in an Angular application? There are different approaches to implementing authentication and authorization in an Angular application, but here is a high-level overview of a common approach. First, use a backend service or identity provider to handle user authentication and provide access tokens. Second, store the access token in a secure way, such as using HTTP-only cookies or local storage. Third, create an Angular HTTP interceptor that automatically adds the access token to outgoing requests. Fourth, create an authentication service that provides methods for login, logout, and checking the current user's authentication status. This service should also handle refreshing the access token when it expires. Fifth, use Angular's route guards to control access to protected routes based on the user's authentication status and permissions. Here is an example implementation of the above steps. First, use a backend service or identity provider, such as Firebase Authentication or Auth0, to handle user authentication and provide access tokens. Second, store the access token in local storage using the local storage API. You can also consider using HTTP-only cookies for added security. Third, create an Angular HTTP interceptor that automatically adds the access token to outgoing requests. Fourth, create an authentication service that provides methods for login, logout, and checking the current user's authentication status. This service should also handle refreshing the access token when it expires. Fifth, use Angular's route guards to control access to protected routes based on the user's authentication status and permissions. Can you describe the purpose of the NgModule in an Angular application and how it helps with organizing the application? NgModule is a core building block in Angular applications that is used to organize and configure the application. An NgModule is essentially a container that groups together related components, directives, pipes, and services, and provides a compilation context for the application. The purpose of the NgModule is to provide a way to organize and modularize the application into smaller, more manageable pieces. By breaking the application down into smaller modules, it becomes easier to maintain and scale, and it is also possible to selectively load different parts of the application depending on the user's needs. In an NgModule, developers can define a set of providers, which are essentially the services that are used within the module. The NgModule can also define the components, directives, and pipes that are associated with the module. One of the main benefits of using NgModules is that they enable lazy loading of application functionality. By splitting the application into smaller modules, the application can be loaded more quickly and efficiently, as only the modules that are needed at any given time are loaded. NgModules also provide a way to share functionality between different parts of the application. By defining shared providers and components in a module, they can be easily reused in other parts of the application. Overall, the NgModule is an important concept in Angular applications, helping developers to organize and modularize their code, and enabling lazy loading and code sharing between different parts of the application. By using NgModules effectively, developers can create more scalable, maintainable, and efficient Angular applications. Here is an example of how an NgModule can be used to organize an Angular application. Let's say we have an application that allows users to browse and purchase products. We can break the application down into several feature modules, each responsible for a different part of the application. For example, we might have a products module that contains components and services related to browsing and purchasing products. We might also have a cart module that contains components and services related to managing a user's shopping cart. Here is an example of how we might define an NgModule for the products module. In this example, the products module imports the common module, which provides common Angular directives and pipes, and declares the product list component, which is responsible for displaying a list of products. The module also provides the product service as a provider, which is responsible for fetching and managing product data. By breaking the application down into smaller feature modules, we can more easily manage and maintain the code and enable lazy loading of application functionality. Can you explain the concept of dependency injection in Angular and its benefits? In Angular, dependency injection, D is a design pattern that allows the application to define the dependencies of a component or service in a separate location and then inject them into the component or service at runtime. D provides a way to make components and services loosely coupled and easier to test. In D, dependencies are declared as providers in an Angular module, and the injector then creates instances of those dependencies when they are needed. When a component or service requests a dependency, the injector provides it to the component or service. The benefits of dependency injection in Angular include: first, loose coupling. D makes components and services loosely coupled, allowing them to be tested and modified independently of each other. Second, reusability. By separating dependencies from components and services, they can be reused across different parts of the application. Third, testability. D makes it easier to test components and services by allowing you to mock or replace dependencies with test-specific implementations. Fourth, maintainability. D helps to improve the maintainability of an application by reducing the complexity of managing dependencies and making it easier to refactor code. Fifth, scalability. D makes it easier to add new features to an application by allowing you to add new components and services without having to worry about managing dependencies manually. Overall, dependency injection is a powerful design pattern that can help to improve the modularity, testability, and maintainability of an Angular application. By using D, developers can build more robust and scalable applications with less code and less effort. How to create custom pipe directive and custom component directive? Here is an example of a custom pipe directive in Angular. Step 1. Create a new file and name it mypipe.pipe.ts. Step 2. Import the required dependencies. Step 3. Add the @pipe decorator to your class and specify the name for your pipe. In this example, we are creating a pipe with the name mypipe. Step 4. Define the transform method to implement the logic of your pipe. In this example, we are converting a string to uppercase. Step 5. Export the class. Once you have created your pipe, you can use it in your templates like this. This will apply the mypipe pipe to the myString variable and convert it to uppercase. You can also chain multiple pipes together. This will apply both mypipe1 and mypipe2 to the myString variable in sequence. Here is an example of a custom component directive in Angular. Step 1. Create a new file and name it mycomponent.directive.ts. Step 2. Import the required dependencies. Step 3. Add the @directive decorator to your class and specify the selector for your directive. In this example, we are creating a component directive with the selector myComponent. Step 4. Define the constructor and inject the component factory resolver and view container ref services. Step 5. Implement the NgOnInit method, which will be called when the directive is initialized. In this example, we are creating a new instance of the myComponent component and adding it to the view. Step 6. Export the class. Once you have created your directive, you can use it in your templates like this. This will apply the directive to the myComponent element and create a new instance of the myComponent component within the view. The myComponent component should be defined in a separate file, for example my.component.ts. For more videos Angular interview question, please subscribe the channel and hit the notification icon. How would you handle data communication between Angular components that don't share a parent-child relationship? There are several ways to handle data communication between Angular components that don't share a parent-child relationship. 1. Service. You can use a service to create a shared data store that can be accessed by any component in your application. This service can have methods to read and write data, and components can subscribe to changes in the data. This approach is suitable for small to medium-sized applications, and it provides a simple and efficient way to share data between components. 2. Event bus. You can use an event bus to communicate between components. An event bus is an object that acts as a centralized communication hub that components can publish events to and subscribe to. When a component publishes an event, all subscribed components will receive the event and can act on it as needed. This approach is useful for larger applications with many components that need to communicate. 3. RxJS. You can use RxJS to create observables that can be subscribed to by any component. An observable is a stream of data that can be observed by multiple subscribers. Components can subscribe to the observable to receive data, and they can also emit data to the observable. This approach is suitable for applications that require complex data flow management. 4. Message service. You can use a message service to send messages between components. A message service is a centralized service that manages messages and routes them to their intended recipient. Components can send messages to the service, and other components can subscribe to messages to receive them. This approach is useful for applications that require asynchronous communication between components. The approach you choose depends on the specific requirements of your application. Each of these methods has its advantages and disadvantages, and you should choose the one that best suits your needs. How do you handle errors in an Angular application? In an Angular application, there are various ways to handle errors. Here are some common approaches. First, error handling service. Create a service that handles errors and displays them to the user in a user-friendly way. This service can be used to catch and handle errors globally across the application. Second, global error handling. Use the Angular error handler to catch and handle errors globally. This can be done by creating a custom error handler that logs errors or displays them to the user in a user-friendly way. Third, observable error handling. When using observables, you can use the catcher operator to catch and handle errors. This can be useful when making HTTP requests or working with other asynchronous operations. Fourth, form validation. Use Angular's built-in form validation to prevent errors and ensure that the user enters valid data. This can be done using Angular's form group and form control classes. Fifth, logging. Use console logging to debug errors and gain insight into what is causing them. This can be useful for developers when troubleshooting issues during development. Sixth, error interceptors. Use Angular's HTTP interceptor to intercept HTTP responses and handle errors. This can be useful when making HTTP requests and handling server-side errors. Overall, error handling is an important part of building a robust and reliable Angular application. By using a combination of these techniques, you can ensure that your application handles errors gracefully and provides a good user experience. Can you explain the concept of observables in Angular and how they can be used to handle asynchronous data? Observables are a core feature in Angular for handling asynchronous data streams. They are a way to represent a sequence of data, which can be observed over time. Observables are used extensively in Angular for handling events, data streams, and HTTP requests. In essence, observables are like a stream of data that can be observed over time. They can emit 0 or more values, and can also emit an error or complete event. Observables can be used to handle events, such as user input or HTTP requests, as well as data streams, such as data from a backend API. One of the key advantages of using observables in Angular is that they provide a consistent and powerful way to handle asynchronous data. With observables, developers can easily handle data that arrives asynchronously without needing to worry about callbacks or complicated event handling. Observables can be created using the RxJS library, which provides a wide range of operators for manipulating and transforming observable data. For example, developers can use operators such as map, filter, and reduce to transform and manipulate observable data. In Angular, observables are used extensively for handling data from HTTP requests. For example, when making an HTTP request to a backend API, the request will return an observable, which can be subscribed to in order to handle the data when it arrives. Here is an example of how an observable can be used to handle HTTP data. In this example, we use the HTTP client service to make an HTTP request to an external API. The response from the request is returned as an observable, which we subscribe to in order to handle the data when it arrives. We also handle any errors that may occur during the request. Overall, observables are a powerful and flexible way to handle asynchronous data in Angular applications. By using observables, developers can easily handle data streams, events, and HTTP requests, and manipulate and transform the data using RxJS operators. How do you implement internationalization in an Angular application? Internationalization, I18N, is the process of adapting an application to different languages and cultures. In an Angular application, internationalization can be implemented using Angular's built-in support for I18N. Here are the steps to implement internationalization in an Angular application. First point, enable I18N in your Angular project by running the following command in the terminal. Second point, mark the translatable text in your HTML templates with the I18N attribute like this. The @ prefix specifies a message ID for the translation message. Third point, extract the translatable messages from the HTML templates using the following command. This command will extract the messages to a file named messages, XLF in the src local folder. Fourth point, translate the messages in the messages.xlf file using a translation tool such as Google Translate or a professional translation service. Fifth point, generate a translation file for each language you want to support. For example, to generate a translation file for French, run the following command. This command will generate a file named messages.fr.xlf in the src local folder. Sixth point, serve the application with a specific language by specifying the configuration flag. For example, to serve the application in French, run the following command. This will load the translated messages from the messages.fr.xlf file and display them in the application. Seventh point, use the Angular translate pipe to display the translated text in the application. For example, to display the translated welcome header message, use the following code. This will display the translated message for the current language. Repeat steps 4 to 7 for each language you want to support. That's it. With these steps, you can easily implement internationalization in your Angular application. Thank you. If you liked the video, please like, share, and subscribe. Share and subscribe.